true. So in this case, what is it going to be? What's x not going to be? Oh, so maybe I'm sorry. No, I don't. I'm not going to pick any today.
5 and 1.
Yeah. So 5 is going to be my x here. X naught. And we're going to do plus 2t. Someone other than Amy, where the heaven did 2t come from?
T times the first number, the x bar.
Right, so it's like the x coordinate of your direction vector, right, times t. Now I know I'm going very slow here, but I've got to make sure this is fundamentally important. As Michael only knows, this gets more complicated by the day. If you remember how I talked about the difficulty? Remember we talked about the difficulty and it starts like this and all of a sudden does this? This here is a perfect example of that. So this stuff right here, you can completely understand and master before you go on. Okay, so that said, can someone else give me the y, please? Nate, go. Yeah, 4 minus t. Part B, sort of a hokey question, but I'm going to say this. Where does this line, does this line intersect the y-axis? Okay, because intersections are a huge part of this unit. Can someone be brave and give an attempt at this one? Joe, go ahead.
Set t to 4, so y equals 0, and then put 4 in for t next.
Yeah, okay. So what you're going to do basically is you're going to, okay, for when you intersect the y-axis, you know that x equals 0, right? Right? We intersect the y-axis, x equals 0, right? So base you're looking for 0 and k I'm going to use. Okay. I think you got it backwards, Joe, what you said there. I think you got it backwards. I think I got that backwards, yeah. Okay, so 0 comma k. So what you're going to do is you're going to solve this equation. Here we go, guys, and this is something that's fundamentally important. You're going to use parametric form. I like parametric form because it's algebra, and I like algebra because I'm a math teacher. So you're going to simultaneously solve 2 equations. The first one is this one. The second one is this one. Can someone be brave and tell me where the heaven I got those numbers from? Uh-oh. Oh, goodness. I had a freeze there. Okay, oh my goodness. Heaven. Right? Like this is like any point on my line is x and y here, right? This is any point on my line. So my point on my line I'm looking to find is 0 and k. I just chose k as any value. Okay. Great. Can someone be brave and tell me what to do next? I have 2 equations, 2 unknowns, hints. Substitution, lovely, okay? If you want to eliminate, you can, but I'm not going to. I'm going to say negative 5 equals 2t. T equals negative 5 over 2. Are we okay on where that came from? Because we'll be doing this but 100 times more difficult. Sorry, I don't mean to be mean. Am I too honest?
Well, it's better than not telling them it'll.
Okay, it's going to get 100 times worse than this, okay? I'm going to be the good cop today. You'll love it. All right, great. So to get my k value then, so then k is going to be 4 minus negative 5 over 2. So k equals 8 and 5 is 13 over 2. Okay, someone other than Evan. Evan, you're in the zone today. Someone other than you that I'm going to pass on to you. What does that actually tell me? What have we just found out? Yeah, the y-intercept. Okay, so therefore, the point at the point 0, 13 over 2. All right, we have enough for 2-dimensional vectors. Can we move on to 3D? Okay, so it's the same thing, right? There's not much to do beyond that. Did I miss anything on this last one?
So T is just a number.
T is just a number like that you're multiplying by, right? So I'm going to use deaths as an example because I like it. Let's pretend this is my favorite point, okay? And my direction vector is in front of your desk.
Yeah.
All T is telling you, okay, well, either go over 1 desk, 2 desks, 3 desks, and that's going to make an infinite line this way. That's all they're saying, okay? Does that make sense, that logic? Because when you see 3D, it's harder to visualize, okay? Not for you guys, because they're all geniuses of vectors, okay? But for me, it's harder to visualize, all right? Okay, good? Okay. Did I miss anything on the note? Oh, a normal I missed, okay? A normal vector is a line, a normal vector to a line is perpendicular to the line. And for the equation, for ax plus by plus c equals 0, n hat equals a comma b. So you can guess we will be doing some crossing in this unit for sure. Okay, when we get more vectors going on there. Okay. We'll deal with this a little bit later on here. That's terminology. We'll deal with 3 dimensions because you can't cross in 2 dimensions. Okay, fears yet? Well, haven't lost somebody yet? Okay, this is like OSCVI. I'm sorry, I should go ahead, Evan. Oh, these are just coefficients. This is just standard form of an equation. Okay, because what we're doing in this unit is we're taking all these vectors and we're putting them into things we can manipulate with algebra, which makes me tremendously happy. Okay, you guys like angles and stuff. I like algebra. That's why I teach math. Okay, so what we're doing is in this unit we're trying to find vectors and turn them into algebra. That's what we're doing. Yes.
Why is there only 2 points in the end if it's 3D?
This one isn't 3D yet. We haven't started 3D yet. This is the last node of the 2D section. Then we'll move on to 3D. Okay, we're going to extend this to 3D. All right, here we go. 3-dimensional vectors in 3 space. This is going to be almost the same thing that's on your note. 3 space at all? 3 space. This is going to be the very same thing that's on your note for the terminology here, but I got to make sure the logic here is good. So we're going to say if point P is x naught, y naught, z naught, and M equals ABC, we're going to say the vector equation of the line is going to be R equals P plus TM, or R equals x naught, y naught, z naught, plus T in BC. And this should not be too shocking that, actually that should be vector this. And that should not be too shocking. It's the same definition as before, but we're in 3 dimensions instead of 2 dimensions. Okay, with that vote of confidence, could somebody tell me the parametric equation of the line in 3 dimensions? Somebody brave. Without looking at your note, we're just thinking with this, okay? So just use this. What's the parametric version going to be? Go ahead. Say x is equal to x naught plus TA, y is equal to y naught plus TB, and z is equal to z naught plus T. Excuse me. Okay, we're going to do the same thing as the last example except in 3 dimensions. So I'm going too fast here, but hopefully you at least glanced over the lesson there. Hopefully this is making it clear. That's what it's supposed to happen. Any questions here? It's the same thing as it before, but in 3 dimensions. Okay. And again, looks like that should be a subscript C. That should be a real C, not a subscript C. And the same thing when you get to university and they talk about something in n dimensions, right? You can see how this would just extend the same way. Okay, right? You get to 4 or 5, 6, whatever you need to go get. Don't be afraid. It's hard to visualize something in 6 dimensions, yes. Okay, right? But you can calculate it, no problem. Right? Okay, good. Example 4.
On the left for the point gives.
Yes, I do. It is a point, but it's It's a point, but it's in a direction vector though. I don't think I should. You just gotta shut me out. No, I'm leaving it as a square bracket. Because what's going to happen is vector p. If we're doing our point on the line, this is what the diagram was supposed to say there, okay? That's going to be like, that's the direction. It's like this is vector p right here. From there to there. Okay, and then you're going to have your analog like that. That's how it's going to work. All right, so let's do another few examples here. Then we're not going to stop early because the principal could be watching this video. Example 4. Okay, it says find the metric and parametric equation of the line. Oh, I get it. Between the points. A is going to be okay, do your best. Okay, so it should be the same as we did before, but we're using 3 dimensions to do it this time. And I'll